Hello, for my ECS 2021 computer organization product, I've created a digital sensor that's able to accurately get the temperature using the temperature sensor and display it on an LCD. I've also programmed many features into this, such as changing the way the LCD displays information, changing the precision of the temperature, and changing what unit it will use to display the temperature. The LCD also has a cool feature where it's able to change the color of the backlight and even mix the colors as well. Here I've recorded a video of me using it. We're using a PIC32MX 220-0F2B to use a temperature sensor using one wire to get the temperature accurately. As you can see here, I'm going to show me changing the view mode, and this is able to show the time it's been on as well as the temperature. Here the temperature is able to be shown there. I'm also able to change the precision with the second button. This goes up to precision 12 and basically shows extra decimal places based on how accurate it can calculate. The third button is for changing the units of the temperature from Fahrenheit, Kelvin, and Celsius. The last few buttons are for basically what the color of the button is, red, green, blue. I'm able to change, mix, and match the colors based on the button color. This allows me to basically have a few assortment of colors and change how the LCD looks. Right now I'm going to be showing how that when I take the temperature sensor out, it will basically show that there's no temperature sensor in, and it'll be able to detect that and not do anything and just say, hey, there's no temperature sensor. This is really cool because now we can easily detect and display a message like that. The whole circuit runs on a battery pack with 3 AA batteries and is able to be easily turned on and off whenever I want it to be. Now, what I'm going to be showing you here is the wiring without the LCD. This is the LCD, and I had to solder on the pins here, and I had to learn soldering how to do this. It was really fun to do. Here, I'm going to be showing you the wiring under the LCD. I managed to assort all the wires underneath and put them to the direct pins such that it's easy to use and not too messy. I was limited by wire and I had to sort of makeshift some of them and bend some of them, but I think it looks good. Now, this is a temperature sensor. What this temperature sensor does, it has 3 pins basically. One is for ground, the middle one is for communication to the sensor, and that communication is very important because every few milliseconds I have to send it information, either a 1 or a 0, about 8 times so that it can communicate with it and do something, such as converting the temperature. The last one is for power. In this video I recorded earlier, I've shown that I've been able to get the temperature of the sensor to detect hot air with a blow dryer. This temperature sensor is able to do very high temperatures and even low temperatures. Here I've gone through the process of heating it up and getting up to roughly, I believe, 80 degrees. As you can see here, it's kind of faint, but it went up to like 70 at the start. I'm also able to go into the negatives. I can't get it too far in, but I've been able to put it in the freezer and got roughly negative 12 to 13 on the freezer, but it cools down really quick because of the room temperature. Getting negatives was kind of complicated. At first, I was using only unsigned bits that weren't able to detect if it was a negative, but I managed to change the code and resolve this issue right here. Okay, now that I've shown you how it looks and how it works, I'll be showing the code, and I'll even be leaving all the code in the description of this video. I hope that other people can learn from it, and I hope that this helps other people as well. Okay, here's my code. Over here is all the important configuration bits that are required to use the PIC32. Most of these include configuration of the internal clock. We will configure it to be 40 hertz and 40 megahertz configuration. Many of these are not too important to understand, but this one in particular most of these is kind of important. Configuration for an interrupt that will configure it to be 40 occurs about every 40 megahertz, so that we can, one, keep track of the time that it's been on, and two, configure all buttons and make sure that when button is pressed, it responds quickly. The reason I have this here is because doing this is not probably the best way to do it, but setting up interrupts are kind of hard to do in my opinion, and the documentation in there isn't too great and hard to understand. But this is basically how I've decided to do it for now. This one right here basically clears the flag. That's why we need to do this is because if we don't clear it, then the program won't know that we've gone through this interrupt basically. We also make sure to reset the timer and increase the time. So over here, we set up a string basically, and then we configure our timer. This part configures the timer, and this assembler function tells it to enable interrupts. And then we make sure that any flag that might have occurred is cleared and set the priority of it to 1. Over here, we make sure to change all inputs on port A to analog, and all ports to port B to analog as well. All ports on port A will be output, while over here only a few, based on this hexadecimal, will be an input or an output. How we know which ones will be is based on our header file that we define over here. And over here, I've defined and made it as general as possible to use this program in other ways. I've defined stuff for the LCD bus, LCD color, the temperature sensor, and the buttons. So you can mix and match these just by changing these defines. Now back to here. What we do here is we initialize the LCD, and how I have it set up is in 4-bit mode. The LCD is able to run in 8-bit and 4-bit, but I decided to run it in 4-bit so that I had more pins on my microcontroller to use for other things. How this is set up is not too important because the documentation gives us sort of a way to do this, but here is kind of important because we tell it that we're doing it in 4-bit mode and that we're going to have 2 lines. We also make sure that the backlight is on for red as default, while making sure any blue and green is off. Later in the code we're able to change that, but for now I've decided to have red as the default one. This is where we have a way to check if the sensor is actually on. And if it's not on, we tell the user that there's been an error and that we have not found the sensor. How we check this is by sending the sensor a pulse, a reset pulse, and if it responds on early, and we'll send basically a 0. We'll be able to detect a 0. But if it doesn't respond at all, that means that there's no sensor, or we've wired it wrong. That means it's not ready to work, and there's no point in trying to calculate any temperature. What we've done here is I configured it to calculate the temperature with a function. Unfortunately, for whatever reason, either the compiler or something weird in the code doesn't allow me to return a float properly. I'm not sure what it is, but I have to end up having to do a makeshift version of sending an integer and converting into a float later. Over here in the code, there's not much we can do here other than communicate with the sensor and then calculate whatever we've gotten from that sensor. It's kind of a long file and a lot of work to actually communicate it, solely because the sensor requires that we communicate it with one wire. It's very interesting how we can actually communicate solely with one wire, and the timings of this wire and the order of how we communicate it are very important. Over here, this is what we'll do in order to get all the memory from the sensor. What we do is we send it a reset pulse telling it that we're going to be going into a mode that we'll be able to write a command to it. Then we tell it to skip the ROM. The reason we do this is because the sensor allows us to communicate and use multiple sensors on one bus or wire, and we can also use this so that we can select a particular sensor, but for now we only use one. Here we tell the sensor to convert the temperature and put it into degrees centigrade. Now based on precision of our sensor that we define, the conversion can take anywhere between 100 milliseconds to 750 milliseconds. This is kind of important because the precision changes how much we can actually see, and the calculation actually takes longer each time. Over here we redo the reset pulse, and then we do the skip ROM like we did last time, but we change the command that we write to it to read the whole entire scratchpad, and we collect all of those in an array that we define at the top. Then after that we use this formula. Temperature equals truncating the red temp by 0.5 degrees Celsius, or bit 0, and basically shifting it left. And subtract that by 0.25. Add count per C, subtract count remain, we can divide that by count per C again. This allows us to calculate the temperature accurately. After that, we have to check if it's signed, and this is how I easily been able to get temperatures in negative and positive. And then we simply use this to convert the temperature to Kelvin or Fahrenheit, or leave it in degrees Celsius based on what the user wants. Other than that, that's mostly what we do. I've also configured buttons, but that is not too important, as all it does is change either what the LCD shows or the backlight of the LCD. Thank you for watching the video. Bye.